You know that feeling when you look at a string of numbers and symbols and your brain just kind of shuts down? Well, today we're going to crack the code on exponents. They look intimidating, for sure, but they're actually one of the most powerful and honestly elegant shortcuts in all of math. Let's kick things off with a really, really big problem. Okay, get a load of this. That number right there, that's the mass of the planet Uranus in kilograms. It is an absolute monster. And let's be real, it's a total nightmare to read, a pain to write, and forget about trying to use it in a calculation. You'd need a screen the size of a bus. Yeah, you're probably thinking the same thing I am. There has to be a better way. I mean, trying to juggle all those zeros is just asking for a typo. So that's the problem we're setting out to solve today. There needs to be a better system. And spoiler alert, there is. And this is where our hero steps in. Exponents are the secret weapon we use to tame these ridiculously huge numbers and wrestle them into something we can actually work with. So what exactly is an exponent? Let's break it down real simple. You've got an expression like 8 squared. The big number on the bottom, the 8, we call that the base. The little number floating up top, the 2, that's our exponent. And all it's telling the base to do is multiply by itself that many times. So 8 squared is just 8 times 8. That's it. That's all it's doing. Okay, quick clarification here, because this trips a lot of people up. You'll hear exponent and power used all the time, sometimes for the same thing. But technically, the exponent is just the little number. The power is the whole shebang, the base and the exponent together. It's a small detail, but getting it right helps everything else make sense. All right, if you remember only one thing from this section, make it this. At its heart, an exponent is just a shortcut. It's lazy multiplication, and I mean that in the best way possible. It saves us from writing out these long, annoying strings. Once you really get that, all the rules we're about to cover are going to click into place. All right, basics are down. Now it's time to build our toolkit. And listen, these aren't just a bunch of random rules you have to cram into your brain for a test. They are logical, smart shortcuts that just work. They let us play with exponents easily. So here it is, your cheat sheet. Think of these 3 rules, the product, quotient, and power rules, as the MVPs of exponents. They're the workhorses that handle multiplying, dividing, pretty much all the fun stuff. We're going to break down the why behind the first 2 right now. Let's start with the product rule. Now, the key here, and you really got to pay attention to this part, is that the bases have to be the same. If they are, then multiplying is super easy. You just add the little numbers up top. And here's why this isn't just some math magic. If you actually spell it all out, right? X squared is just x times x. And x cubed is x times x times x. So when you multiply them together, well, how many x's do you have now? You've got 5 of them, so x to the 5th. Adding the exponents is just a fast way of counting. Okay, so what about the opposite? What about division? Well, the logic is pretty much the same, just in reverse. Again, the bases have to match. But this time, instead of adding, you just subtract the bottom exponent from the top one. And once again, let's prove it. No magic here. Just write it all out. 5 x's on top of the fraction, 2 on the bottom. What happens? 2 from the top cancel out 2 from the bottom. And what are you left with? 3 x's right up top, x cubed. See? Subtraction is just a nifty shortcut for canceling things out. Okay, we've handled the nice, straightforward rules. Now we're going to venture into some of the weirder territory. These next couple of rules might feel a little counterintuitive at first, but stick with me because the why behind them is actually really cool. And here it is, the classic, the one that gets everybody. Why on earth does anything to the power of 0 equal 1? I mean, it feels so random. Shouldn't it be 0? How can you multiply something by itself 0 times and somehow end up with 1? It's just weird. Well, the secret isn't in some crazy complex formula. It's actually just hiding in a simple pattern. Check this out. To get from 5 cubed down to 5 squared, you just divide by 5. To get from 5 squared to 5 to the first, you divide by 5 again. So what's the next logical step to get to 5 to the 0? You've got to follow the pattern. You divide by 5 one more time. And what's 5 divided by 5? It's 1. The pattern demands it. It has to be 1. Now this idea right here is the key to finally understanding negative exponents. Think about it. If a positive exponent means repeated multiplication, what's the total opposite of multiplying? It's dividing. So it just makes sense that a negative exponent means repeated division. So here's the formal rule. When you see a negative exponent, just think flip it. All it's telling you to do is move that entire expression to the other side of the fraction line and make the exponent positive. So x to the negative n just becomes 1 over x to the positive n. It's simply the inverse. Okay, we have built our toolkit. We have unlocked the mysteries. Now it's time for the payoff. Let's circle all the way back to that giant, messy number from the beginning and see what we can do with it now. Remember this guy? The mass of Uranus? This absolute beast of a number. So many zeros just sitting there, waiting for you to make a typo. It's impractical, it's unwieldy, it's just a mess. And now, look at it. Using scientific notation, which is totally powered by exponents, we can rewrite that entire monster like this: 8.681 times 10 to the 25th power. It's the exact same number, but now it's clean, it's compact, and you can actually use it. That right there, that's the magic of exponents. And don't think for a second this is just some abstract trick for astronomers. Exponents are running the world behind the scenes. They're in your bank account calculating compound interest. Biologists use them to model population growth. They're the reason your phone is 1,000,000 times more powerful than the computers from the moon landing. They are literally everywhere. And that brings us to the real point of all this. The goal was never to just memorize a list of rules. It's about understanding that core idea, that it's all just a shortcut for multiplication. Because once that really clicks for you, you don't even need to memorize the rules. You can figure them out on the fly, just by thinking it through. And that's where I want to leave you. This whole journey of taking something that looks impossibly complicated and finding this simple, elegant idea hiding inside, well, that's not just about exponents. It kind of makes you wonder, right? What other rules in math or in any other subject are we just memorizing when a much deeper, more intuitive understanding is just waiting to be unlocked?